Good morning, students. We'll continue with our topics related to equilibrium. We have discussed the various theories, students, and I have discussed with you the ionization constant, the pH concept. Now I'm taking di and poly basic acids and di and poly acidic bases. Now some acids like oxalic acid, sulfuric acid, phosphoric acids have more than one ionizable proton per molecule of acid, and such acids are known as polybasic or polyprotic acids. And the dibasic acids are those acids which have more than two ionizable proton. Tribasic means more than three, and higher order of ionization constant are smaller than the lower order ionization constant. It should be remembered, students, these acids like sulfuric acid, oxalic acids, they have more than one ionizable proton, right? And their basicity is more than one, which are known as di or polyprotic acids. So how these acids dissociate, the phenomena is same. First of all, let us take one example. Suppose we have one dibasic acid, that is H2X. When it dissociates into H ions plus HX negative ions. Again, HX negative ions dissociate into H positive ions and X2 negative ions, right? So when we'll write the dissociation constant, we will write twice, because for first equation we will write the value of K, that is dissociation constant will be Ka1, and for second it will be Ka2. And remember, Ka and Ka2, they are known as first ionization and second ionization constant or dissociation constant, students, right? तो एक से ज्यादा अगर हमारे पास प्रोटॉन रिलीज हो रहा है तो उनके लिए जो हम डिसोसिएशन कांस्टेंट की वैल्यू लिखेंगे वो भी एक से ज्यादा होगी, राइट? फॉर डाई एंड पॉली इट शुड बी मोर देन वन, right? The same is for the bases, students. For bases also, we must take the different ionization constant, dissociation constants. Just remember that Kb1 is greater than Kb2, and similarly Kb2 is greater than Kb3, right? So हम different क्या ले सकते हैं, dissociation constant ले सकते हैं, और हमेशा पहले वाले dissociation constant की वैल्यू ज्यादा होती है as compared to second, as compared to third. Now, what are the factors affecting the acid strength, students, right? What are the factors on which it depends upon the extent of dissociation of an acid, right? The extent कितना break होगा हमारे पास acid, उसकी क्या strength है वो depend करता है polarity कितनी है, students. Strength of any bond, suppose we have Ha bond, decreases as the energy required to break the bond decreases, right? Or we can say that to check the extent of dissociation of an any acid, that depends upon the polarity, no doubt, right? So as the size of A increases down the group in the periodic table, Ha bond strength decreases, so the acid strength increases. Or if the electronegativity of any suppose A increases, the strength of the acid also increases. Like we'll take one example, students. I was saying that if an element in the same group of the periodic table, and Ha will be the bond strength, which is a most important factor, student. As the size of A increases down the group, Ha bond strength decreases and acid strength increases. For example, out of HF, HCl, HBr, HI, the acid strength of HI is greater because the size increases, right? So we can easily break the bond. Similarly, if I like talk about the electronegativity, because the strength of an acid depends upon the electronegativity also. As the electronegativity of any element increases, right, the acid strength also increases. For example, out of methane, ammonia, water, and HF, right, students? We can see here the acidic strength of HF is greater. So this is the electronegativity of central atom. This is not atomi, it is atom, students. Remember, it's just a small mistake, that is atom, not ATIOM, right? I think you have clear that strength of any acid depends upon the polarity, and there are the two factors. First, the size, and the second is the electronegativity. negativity of central atom, right? Next topic is buffer. What are buffer solutions, students? Buffer are those solutions which resist pH in the change. Suppose we have a practical, and because of any reason the practical not held at that time, but we have made a solution in a large quantity. So to preserve the solution and to use it again, we must add that substances, those substances which preserve that substance or that solution. सो हमने प्रैक्टिकल करना है और प्रैक्टिकल किसी वजह से नहीं हो पाया, बट हमने बहुत ज़्यादा लार्ज अमाउंट में सोल्यूशन को प्रिपेयर किया है और हम उस प्रिपेयर किया हुए सोल्यूशन को वेस्ट नहीं करना चाहते स्टूडेंट्स, और वी वांट टू रीयूज इट. सो हाउ वी विल प्रिजर्व दैट सोल्यूशन? और जो बिगर लार्ज स्केल पे कंपनीज होती हैं वो सोल्यूशंस को कैसे प्रिजर्व करके रखती हैं? प्रिजर्व करने का मतलब है कि उसमें कोई भी ऑक्सीडेशन या रिडक्शन ना हो जाए, राइट? अगर वो 2 या 3 दिन तक भी वो सोल्यूशन पड़ा रहे, तो उसके लिए हम क्या करते हैं? व्हाट वी suggest or what they people do, they add some buffer solutions. So buffer is that solution which resists the change in pH. क्योंकि अगर solution का pH जिस pH का हम बनाकर गए थे वो उतने ही pH का रहेगा, it means buffer ने अपना काम किया है, right? And how can we check that buffer has done his work? By adding, जब हम वापस आए और हम दोबारा से solutions को observe करें, by adding small amount of acid or a base, और कोई भी स्मॉल अमाउंट ऑफ एसिड या बेस डालने में उसमें फिर भी कोई चेंज ना आए, इट मींस बफर हैज डन हिज वर्क, परफॉर्म द वर्क, राइट? सो बफर सॉल्यूशन कैन बी प्रिपेयर्ड. How it can be prepared? It is of many types, like simple buffer, mixed buffer, and mixed buffer is of course for the two types, that is acidic buffer and basic buffer, right? Simple buffer are the salts of weak acid and weak bases, and mixed buffer, for example acidic buffer if I talk about, that is an equimolar mixture of weak acid and its salt and a strong base. Similarly, basic buffer is an equimolar mixture of weak base, its salt, and a strong acid. If I talk about an example of a buffer, the simple buffer example is ammonium carbonate or ammonium acetate. An acidic buffer, the example of acidic buffer is acetic acid and sodium acetate. Basic buffer is ammonium hydroxide and ammonium chloride. So, buffer are those substances students which resist मतलब होने नहीं देते, रुकावट करते हैं, which resist change in the pH on dilution or with the addition of small amount of an acid or a base, right? So different solution have their different buffer, right? Now springly soluble salts, this is a different concept student. Now some of the electrolytes are soluble in water, right? And some are insoluble or springly soluble in nature. So there are different salts which are springly soluble in nature, right? What are these salts called, right? What are these salts? For example, PbSO4, for example, barium sulfate, they are slightly soluble in water. So now the problem arises, students, how to compare the relative solubilities of these salts. How we can find out the solubility product. So there is a term known as solubility product for these salts, that is represented by KSP. This KSP is the constant known as the solubility product constant. Suppose we have one example of springly soluble. Yeah, it means little affinity for to solubilize with water. MX2, when dissociate, it converted into M2 positive ions plus 2X negative ion. 6MX2 is a solid, its concentration is to be taken, its density and its constant. So how we can represent it? It can be represented like KSP is equal to M2 positive की concentration and X2 negative ions concentration, right? Clear to you? So if suppose one more example is there, AgCl, when you will break it, it will becomes Ag positive ion plus Cl negative ion. But when applying a law of chemical equilibrium, you will write the value of K, Sp. The equation will be concentration of Ag positive ion multiplied by concentration of Cl negative ion, right? So what does this springly soluble salt tell us about? First of all, if we want to define the solubility product, it may be defined as the product of concentration of ions of the salts in its saturated solution at a given temperature raised to the power the number of ions produced by the dissociation of 1 mole of salt, right? And what does it indicates to us? What is the meaning of showing here the springly soluble? Springly soluble salts help us to predict the occurrence of precipitation. Sometimes we mix two salts, students. So sometimes a precipitation occurs, sometimes it do not occurs. Why it is so? Because of some basic concept that is called ionic product, right? The solubility and the precipitation of any salts depend upon the ionic product as well as the solubility product, right? If ionic product is equal to solubility product, अगर हम एक सॉल्ट की आयनिक प्रोडक्ट और सॉल्युबिलिटी प्रोडक्ट की बात करते हैं और वो आपस में बराबर है, इक्वल है, दैट सॉल्यूशन इज नोन एज अ सैचुरेटेड सॉल्यूशन, राइट? एंड the precipitation forms immediately if seed crystal is added. If ionic product is less than, or we can say the solubility product is greater than ionic product, unsaturated solution is there and no precipitation will occur, PPTs नहीं बनेंगे. एंड अगर आयनिक प्रोडक्ट जो है हमारे पास ग्रेटर देन KSP है, तो हमारे पास ओवर सैचुरेटेड सोल्यूशन की बात कर रहे हैं, फॉर्मेशन ऑफ ओवर सैचुरेटेड सोल्यूशन इज देयर एंड प्रेसिपिटेट विल फॉर्म. सो कोई भी सॉल्ट PPTs कब बनाता है? जब उसका आयनिक प्रोडक्ट किससे ज्यादा होता है हमारे पास, उसके solubility प्रोडक्ट से, तो प्रेसिपिटेशन रिएक्शन में जरूर होती है हमारे पास, राइट? एंड इफ इट इज लेस देन, द सॉल्ट विल नॉट बी precipitated and the reaction is known as ionic reaction. And पहले वाली reaction को हम बोलते थे precipitating reaction. This is a basic concept behind the springly soluble salt which help us to predict the occurrence of precipitation. Whether the precipitation will occur or not, how we can identify with the help of ionic product and solubility product. Now the difference arises, the question arises that what is the difference between ionic product and solubility product? So here's the difference. Students, both is exactly same, right? IP expression is exactly same as that of KSP expression. A very little difference is there, that solubility product is used only when the ionic concentration in saturated solution. If I'm talking about the saturated solution, it means I'm talking about a solubility product. And if there is any concentration, the solution of any concentration, whether it is unsaturated or saturated, that is called ionic product. We are talking about the ionic product of that salt. And at constant temperature, KSP value is constant and ionic product value keeps on changing with the ionic concentration even at the constant temperature. Now the common ion effect. What is common ion effect, students? As a name suggests the common ion present. Sometimes when a weak electrolyte dissociate, it produces ions. But if we add a small amount of a strong electrolyte into the weak electrolyte, there is a separation of dab jana, separation of that common electrolyte which is present in them. So ionization of a weak electrolyte is diminished by the addition of a strong electrolyte, which leads to a common ion, is known as common ion effect, or we can define as the separation of weak electrolyte by the strong electrolyte, right, is known as common ion effect, students. For example, acetic acid, which is a weak acid, when it dissociates, it changes into CH3COO negative ions plus H ions. But when we'll add a strong electrolyte, suppose sodium acetate, again it also dissociate into CH3COO negative ions plus Na ions. Now students, here in this both the equation we have two common ions, but addition of this salt suppress the concentration of the above electrolyte, and this separation is known as common ion effect because of the separation is due to common ion produced by both the electrolyte, right? Now the question arises, what is the role of common ion effect here? Again, the common ion effect help us to explain that whether the reaction produces the precipitate or not, right? तो हम जब सॉल्ट एनालिसिस करते हैं प्रैक्टिकल्स में, तो प्रैक्टिकल्स के टाइम पे हम कॉमन आयन इफेक्ट की बहुत सारी एप्लीकेशंस देखते हैं, बेसिकली प्रेसिपिटेशन रिएक्शंस के बारे में ऑब्जर्व करते हैं, right? So here we have finished our ionic equilibrium, but numericals are left, which I'll take in next video. But we have left with one main topic, that is a relationship between the equilibrium constant K, quotient, and Gibbs energy. So student, you must know that Gibbs energy is that energy which is utilized or which is used for a useful work. And I have already talked about the equilibrium constant of a reaction and reaction quotient. And if delta G is negative, right, Gibbs energy हमेशा negative होती है. अगर डेल्टा जी की वैल्यू नेगेटिव है तो रिएक्शन स्पॉन्टेनियस है. स्पॉन्टेनियस मतलब कि विजिबल है and proceed in a forward direction. You must know about this concept. The explanation of delta G will do, delta G is a change in a Gibbs energy, will do in chapter thermodynamics. But here you should know about the relationship between the delta G, equilibrium constant, and Gibbs energy. So if it is positive, the reaction is considered to be non-spontaneous and will proceed in a reverse, it means backward direction. And if delta G is equal to 0, it means the reaction is at equilibrium. There's no longer any free energy left to derive the reaction. So this is a mathematical expression. You no need to do the derivation here, only you have to learn this relationship between K, between Q, and between delta G, right? Thank you very much.